Okay guys, today we're going to look at function inverses. The notation for a function inverse is written as such, and it is read as the inverse of the function f of x. The -1 indicates that it's the inverse of the function given. In this case, the inverse of the function of x. Okay, so let's start by talking about how to find the inverse of the function f of x. First, we replace f of x with a y variable. Then, our second step is to exchange the x and the y variables. Our third step is to solve for y. We're going to add, in this case, add 2 to each side, and then divide each side by 3 to get y by itself, hence solving for y. This is the inverse of f of x. You may note, however, that this inverse is also a function. So we would call this the inverse function of f of x. Inverses are not always a function. And we'll look at an example that is not in just a minute. Here is another function, y equal to x squared plus. It's a function because it's okay for the x to be squared but not the y. So when we exchange our x and y, we get x is equal to y squared plus 1, which tells us that it is, the inverse is not going to be a function because the y is squared. Well, we're going to go ahead and find the inverse by subtracting y from each side. I used a reflexive property to put the y squared on the left-hand side. And then we take the square root of each side, giving us y is equal to plus or minus the square root of x minus 1. So in this case, the inverse of the function at the top of the chalkboard is not a function. We can even explore this by just picking a value for x and finding out whether we get two solutions. So let's pick 5. So we're going to have y equals plus or minus 5 minus 1. We're making x equal to 5. Solving this, we get y is equal to plus or minus the square root of 4, which gives us a solution of y equals to plus or minus 2. So when we plug in one x, we get two y's. So our inverse is not a function. So let's look at another function. G of x is equal to 3x plus 5 divided by 2. I'm going to go ahead and set this equal to y. And then I exchange my x and my y values. And once again, the next step is to solve for y. So I multiply both sides by 2, giving me 3y plus 5 equals 2x. I subtract 5 from each side. 3y would be equal to 2x minus 5, and then divide by 3. This is the inverse of g of x. Again, this inverse is a function. So 2x minus 5 is an inverse function for g of x. If we are given two functions, such as this situation, and we want to know if these two functions are inverses of each other, f of x and g of x, we can use composite functions that we learned about in the last video to find out if they are inverse functions of each other. Note that both f of x and g of x are functions because each x value would give us exactly one y value. So we're going to take f of g of x and we're going to plug into the f of x equation g of x, removing x and putting in g of x in its spot. Now we can simplify this. The 2's will cancel, leaving us x minus 5 and then plus 5. So the 5's will cancel, leaving us x. Therefore, f of x and g of x are inverses, and they are inverse functions of each other. So f of x and g of x are functions that are inverses of each other. Here's two other functions, and let's see if these are inverses of each other. So again, we're going to find f of g of x, and we're going to plug g of x into the f of x equation, giving us 2x minus 1. It does not equal x. Therefore, these two functions are not inverses of each other, because they do not, when you put one inside the other one, it does not equal x. Now, let's say you were requested to find the inverse of the function f of x. So we would start by replacing the f of x with y and following the same steps, exchange the x and y, and then solve for y by adding 1 to both sides and then dividing by 3. This would give us our inverse. But if we wanted to be sure that this inverse was accurate, we could plug it into the f of x function, and if it equaled x, then they would be inverses of each other. Note that the inverse that we found, x plus 1 divided by 3, is a function. So we will now take our inverse and plug it into the original function. So all we did was take this function down here and plug it in for x in the original function. We can then cancel out our 3's, leaving us x plus 1. Sorry about that, went too fast. X plus 1 minus 1. The 1's will cancel, leaving us x. So therefore we are correct. We did find the inverse of f of x. And in fact, it is the inverse function of f of x because it too is a function. Let's look at some graphical representation. This graph represents a function, and we can tell it's a function because it passes the vertical line test. In order to know if its inverse has a function, if its inverse is a function, we're going to use the horizontal line test. The horizontal line test will help us determine if this function has an inverse that is also a function. So we draw a horizontal line across our graph, and we can draw this in any place, but if the horizontal line only crosses the graph one time, every time you draw a line only crosses one time, then the graph, or the inverse of the function represented by the graph, is also a function. Let's look at another function. This is a quadratic. It is represented by the parabola. And we know it's a function because it does pass the vertical line test. But as you can see, when we draw a horizontal line across the graph, it crosses in more than one place. Therefore, the inverse of this function is not a function. Again, because it fails the horizontal line test, the inverse of this function is not a function. It's an inverse, but it's not a function. Okay, so now let's look at it numerically. On the left is a function represented in a t-table. Each x is paired with exactly one y. In order to find the inverse of this function, we simply switch our x's and y's. Now we can look at the x, y's and find in the right-hand side and find out if that's a function. And if you notice, each x also is only paired with one y. So therefore, the yellow t-table represents the inverse function of the function in the white t-table. So if this was g of x, then this is the inverse of g of x, and also is a function. Okay, here are two more t-tables. The t-table on the left represents a function, because each x has exactly one y. Even though the y's are repeated, each of the x's are only paired with one y. So 2 is only paired with 4, and 3 is only paired with 4. But that's okay. You can repeat the y values. The x values can't be repeated unless they have the same y value. Looking at its inverses, however, on the right, the inverse is not a function. Why? Because the x's repeat and the y value associated with them is different. So each of the x's in the yellow one does not have only one y value. As is obvious, 4 has two y values. 4 is paired with 2, and 4 is paired with 3. Well, that's all there is to finding the inverse of a function and then determining if the inverse is also a function. See you in class tomorrow, and be sure to bring me any questions you may have regarding this concept.